Alright, we're going to continue talking about area and perimeter today. Here's a quick review of the formulas. And again, for area, formulas for area. And again, perimeter is just the distance around the outside of a figure, so you just add up all the side links for perimeter. Last time we pretty much had all the information given to us that we needed to jump straight into the area formulas. This time we're going to be dealing with figures where we got to find missing pieces first. So for example, we want to find the area and perimeter of this figure. This is a rectangle. For the area of the rectangle, you need length and width, because area equals length times width. Well, right now I don't have the length or the width, so I'm going to have to do some work to find those things first. Alright, when you take a rectangle and you draw a diagonal through it, you create a couple of right triangles. Notice right here we have a right triangle where we know that the hypotenuse is 4 and that this angle is 30 degrees. I can use my trig to find these missing sides. So again, the 4 is the hypotenuse, it's opposite the right angle. If I'm using this 30-degree angle, this side is opposite the angle and this side is adjacent to the angle. So let's say I want to find the opposite side. So I've been given the hypotenuse, I want to find the opposite. So if you remember your SOHCAHTOA, remember opposite and hypotenuse requires sine. So I'm going to set up an equation using sine. So sine of the angle, 30 degrees, is equal to the opposite over the hypotenuse. So there's the equation. So I just have to multiply both sides by 4. So I got 4 times the sine of 30 is 2. So x equals 2. No, that side is 2. Okay, do the same process for the adjacent side, except for if I want to set up an equation for adjacent and hypotenuse requires cosine. So cosine of the angle is equal to the adjacent over the hypotenuse. And again, to get the variable by itself, I need to multiply by 4, so I'm doing 4 times the cosine of 30. And when I do that, I get 3.464, something along those lines, depending on where you round to. So I now have the adjacent side. So the length is approximately 3.464. The width is 2. And now I have everything I need to find the area and perimeter of a rectangle. So for the area, it's just length times the width. So I'm multiplying this by 2. And the area comes out to 6.928 whatever. And we are rounding to the nearest hundredth. So 8's big enough to round up, so that would be 6.93. The units were not given, but area is always units squared. So I'm just going to put U for units and then squared. And then perimeter, we just add up all the sides. So for perimeter, we're doing 3.464 plus 2 plus 3.464 plus another 2. And when we add all those up, you should get 10.928, which is going to be approximately 10.93. And perimeter is single dimension, one dimension, and so it's just regular units. So there's the area and perimeter of that rectangle. We had to do a little trig to find the length and width first. Okay, next figure we're going to look at is a triangle. So if I want to find the area of a triangle is 1/2 times base times height, or base times height divided by 2. But I need the base and height. Well, the base, notice all these sides are marked congruent. The base always has to be a side, so the base is going to be 8. What I need is height. And remember that base and height have to be perpendicular. And I don't see any right angles in this triangle right now. The height has to be perpendicular to the base, so to create the height, I got to draw it in there. So I need to draw the height in there. So what happens when we have an equilateral triangle and we draw a height in, it's going to split it into 2 congruent parts here, 2 congruent triangles. So that 8 is split up into 4 and 4. And if I want to, I could do Pythagorean theorem to find this piece right here. Or if you don't remember that it's going to split this side up into two congruent parts, remember if it's an equilateral triangle, it's also equiangular. And so because the three angles in a triangle add up to 180, the three angles in an equiangular triangle are each 60 degrees. It's the only thing that they can be to all be congruent and add up to 180. So that 60 degrees up here ends up being split into 30 and 30. So you could also do trig if you prefer to find that height. But either way, I'm going to do Pythagorean theorem. So when I'm focusing on this triangle, the hypotenuse is 8. So make sure that goes in for C. The hypotenuse always has to go in for C. That 4 can go in for A or B. Does not matter which one. So I'm squaring those numbers. 4 squared is 16, 8 squared is 64. I'm going to subtract the 16. And then take the square root to get rid of the squared. And the square root of 48 is approximately 6.928. So what we just found was the third side of this triangle, which is the height of the triangle. So the height is approximately 6.928. So now I have base and height. I can find the area of the triangle. 1/2 times the base times the height. We plug all that in, we get 27.712. We're rounding to the nearest hundredth, so 27.71 approximately. And that's units squared. Now for perimeter, we just add up all the sides. We have 3 sides of 8, so you can do 8 plus 8 plus 8, or you can do 8 times 3. It's the same thing no matter what you're doing. Should get 24 units. Let's try the next one. Okay, this is a rhombus. Notice all 4 sides are congruent. For a rhombus, we got a couple of different ways you can find the area. One is 1/2 times diagonal 1 times diagonal 2. And we actually have everything we need to find the area here. This diagonal is 10, and this diagonal is 4, 2 plus 2. So we have both diagonals, so we actually have everything we need to find the area of this rhombus. You just plug the numbers in, 1/2 times 10 times 4, and you should get 20. So the area is 20 units squared. Now what we don't have right now is all the sides, so we're not really able to find the perimeter with the information we have right now. But remember, in a rhombus the diagonals are perpendicular, so we end up with right triangles. And in this right triangle, I know 2 of the sides. I can find the third side by doing Pythagorean theorem. So the hypotenuse of this triangle is the side I don't know. So the 2 and 5 have to go in for A and B. It does not matter which one's which. 2 squared plus 5 squared comes out to 29. I need to get rid of that squared, so I do the square root because it's the opposite operation. And the square root of 29 is approximately 5.385. Approximately 5.385. Now, if that's the length of a side, and all the sides are congruent, I can just add 5.385 plus 5.385 plus 5.385 plus 5.385, or it's 4 sides that are exactly the same, so I can just do 4 times 5.385. And when we do that, we should get approximately 21.54. Alright, let's look at the next one. We have a trapezoid on the next example. Remember, for area of a trapezoid, the formula is 1/2 times the sum of the bases times the height. Now remember, in a trapezoid, the bases are parallel to each other. So these 2 sides are the bases. We know what one of them is. We know one base is 12, but we don't know what the other base is yet. We also don't know the height. Remember, height has to be perpendicular to the base, and this does not create a right angle with either one of these bases. It is not perpendicular to the base, so it is not the height. So I need to find the height of the trapezoid, and I need to find the length of that base. Okay? Well, a trapezoid can always be split into rectangles and right triangles. And in this case, it's an isosceles trapezoid. And with an isosceles trapezoid, the triangles on each side are always going to be congruent to each other. So we kind of got the same thing going on both sides of that trapezoid on those two triangles. In a rectangle, the opposite sides are congruent. So this is 12. I know that this piece right from here to here is 12. What we need to find is the length of this entire base down here, and we need to find the height. Okay, let's use some trig. We have a right triangle right here. I know this angle. The 8 is the hypotenuse of the triangle. This side is opposite the angle, and this side is adjacent to the angle. So let's say I want to find the opposite first. Opposite and hypotenuse, remember your SOHCAHTOA. Opposite and hypotenuse requires sine. So sine of 60 is equal to the opposite over the hypotenuse. So to solve the equation, I need to get x by itself. It's being divided by 8, so we multiply by 8. So 8 times the sine of 60. And you get approximately 6.928. And that is the height of the trapezoid. Okay, let's find the other piece right here. We need to find the adjacent side. So if I want an equation with the adjacent and the hypotenuse, that requires cosine. So cosine of the angle is equal to the adjacent over the hypotenuse. And to solve for y, I need to multiply by 8. So 8 times the cosine of 60 gives us 4. So I know that this piece right here is 4. Well, remember, these two triangles are congruent. So if this is 4, this is 4. And that means this entire base down here is 4 plus 12 plus 4, which comes out to 20. That entire base down there is 20. So now I finally have everything I need to find the area of the trapezoid. The bases are 12 and 20. And the height is approximately 6.928. So let's plug that in the calculator, find out what we got. You should get approximately 110.85. That would be units squared because it's area, 2 dimensions. And then for perimeter, all we got to do is add up all the sides. So the lengths of the sides, you got 8, 12, 8, and we found out this was 20. So we add up all those sides, and that should give you 48. So the perimeter is 48 units. All right, the next one is a little different because it's not just straight numbers. We have expressions here. This is a square. Notice all the sides are congruent, and we got a right angle. So this is going to be a square. For the square, you can do length times width, or you can do side squared. The length is already labeled as x minus 2. Because the length and width are congruent, all the sides are the same. The width is going to be x minus 2 also. So if I'm doing length times width for the area, that means x minus 2 times x minus 2. Now when we do something like that, we have to distribute. We have to make sure that the x multiplies times everything in this parentheses, and the 2 multiplies times everything inside this parentheses. So we got x times x is x squared. X times negative 2 is negative 2x. So I've distributed the x. Now I got to distribute the negative 2. Negative 2 times x. Negative 2 times negative 2. And a negative times a negative is positive. And then when you finish doing FOIL here, we always have to combine like terms. You got negative 2x and negative 2x. That's a total of negative 4x's. And there is the expression for the area. There's no way to solve this and have it just be a number. But we can get this expression. So we can give the area in terms of x. And then for perimeter, we add up all the sides. So you're doing x minus 2 plus x minus 2 plus x minus 2 plus x minus 2. Or you have 4 sides of x minus 2. So 4 times x minus 2. So 4 times x, 4 times negative 2. So the perimeter is 4x minus 8 units. Alright, and one other thing. This is a little different from the others. This is dealing with the areas of similar figures and how they compare to each other. It says triangle ABC is dilated by a scale factor of 1/3. Dilated is when you blow something up bigger or shrink it down smaller, but you keep the same shape. So you make it a different size, but you keep the same shape. So remember, when two figures have the same shape but different size, those are similar figures. So the original figure, triangle ABC, and the figure that you get after dilating it, the triangle A prime, B prime, C prime, those are going to be similar figures. Now, when you dilate by a scale factor, that means you multiply all the sides by this number. Well, if we multiply everything by 1/3, we're going to make it smaller. It's going to be, the new figure is going to be 1/3 the size of the original figure. So it says, what is the ratio of the area of triangle ABC to the area of its image? So we got area of triangle ABC to the area of triangle A prime, B prime, C prime. That's the way they want the ratio. The ratio of area of triangle ABC to the area of triangle A prime, B prime, C prime. When they tell you they want a ratio, the first thing that's listed always goes on top. The second thing listed always goes on the bottom. Now, we don't know the actual areas, but because of the scale factor, we should know how the areas compare. The original area is going to be bigger because the original area, the original figure is dilated by a scale factor 1/3. Remember, it's going to be made smaller because everything's multiplied by 1/3 to create this figure. So this is going to be the smaller figure. It's going to be 1/3 of the original. So that means the original is going to be 3 times as big as the other one. Basically, I'm just going to flip that fraction, just do the reciprocal, and for every 3 units in the area of the original figure, there would be 1 unit. I'm sorry, I forgot one step. I'm sorry. I'm going to flip that. The 3 is representing the original triangle, and the 1 is representing the new triangle. But remember, area is 2-dimensional, so we always have to square things to get to area. If you got 1 dimension, you got to square it to get to area. So we're going to square these numbers. 3 squared is 9. 1 squared is 1. So you get 9 over 1. And 9 over 1 can just be reduced to a whole number of 9. So the ratio of the area of triangle ABC to the area of its image would be 9. Because all the sides are 3 times larger, the area is actually 9 times larger.